Today, Vitech presents their new Jira plugin, which is aimed at reducing or removing the time that individuals and teams need to spend estimating and categorizing issues. Our plugin, Artificial Intelligence for Issue Analytics, or AIIA for short, provides a platform that the whole company can benefit from. Hi, my name's Maclay, and I'll be showing you through the key details of our product. But first, let me introduce the team to you. The team consists of myself, Kyle, David, Oliver, Matthew, and Arvin. We're all completing a Bachelor of Computer Science at the University of Wollongong. In developing this product, we wanted to assess what our potential impact could be. The Q1 earnings for this year show that Atlassian has an extensive user base across their platforms, with clear growth in both consumer and technical capacities. Upon assessment of the Atlassian marketplace, we identified two areas that could provide a potential for a market. The first of these is an AI-enhanced plugin, and the second is the visualization of performance-critical issues. SMEs will benefit most from the application of this plugin, especially those that have an existing backlog of comprehensive issues. By this, I mean issues that have all of their fields completed, especially story points, priority, and issue type. In doing so, they will benefit from freeing up the project manager to focus on the big picture, tackling the critical path, and planning sprints. Additionally, the software developer will have fewer distractions and a reduction in mental load of those secondary tasks. The machine learning component resides on the issue viewer glance. Recommended values will be populated in the glance for the user to select to be updated. This can occur manually or when trust for the system has been developed automatically via the settings page. The clock icon in the top right of the issue glance will hold the history of values in the fields and provide the user with a method to undo changes. The visualizer provides a network graph of related issues and allows the team to get a high-level overview of the project. These graphs can also be filtered based on the standard relations that Jira provides, such as blocker or duplicate. Furthermore, research has been conducted into assessing the similarity of tasks, and this will be able to be implemented as an additional filter. Here we're going to show the features of the recommendation part of the plugin. We can see that very few of the issue fields have been populated. If we click on the glance button, Generate Recommendations, the plugin assesses the description given by the user and provides some suggestions. Here, the user doesn't want to update the story points and thinks that this issue isn't really an instrumentation component. Although, notice the undo button can revert this change. After clicking Update, the page is refreshed and the updates can be seen. If the user wishes to undo these changes, they can re-enter the Generate Recommendations glance and click on the History button in the top right.
Shown here is the History feature. When the plugin updates the field values, it will save the previous values and allow an unlimited rollback of the fields till the first changes. This feature has been implemented to allow the user to build trust in the AI features of the plugin. Once trust has been developed in the platform, the user may opt to automatically update some or all values. Even then, the history will still be available to the user.
Once we have enabled the visualizer in the settings page, it is available from the project screen. When the user enters the visualizer, they are presented with the entire project, but then they can search for a specific issue to reduce the scope of the view. If the user clicks on the issue, the pop-up provides some additional information. Here, the title is shown. The user can also use this pop-up to navigate directly to the issue. And finally, here you can see the user toggling the filters. It is responsive and intuitive. As promised, we have some technical content to cover. we would like to give some insight into how this plugin works. Jira Cloud is the entry point for the user and provides all of the interactive elements of the plugin. The ACE framework then connects all of our services to this interface. For the machine learning component, we have developed a Flask API that allows us to be more flexible in the setup and running of the model. And then the visualizer reacts to different filters and searches occurring from the Jira interface. In doing so, it requests updates to the graph from the database. Atlassian User Interface, or AUI, is used to provide the interactive elements, ensuring that user experience is consistent and familiar. This example here shows part of the glance on the issue page. Elements, including iconography, fonts, and colors, have all been selected in accordance with Atlassian guidelines. This process extends throughout the plugin. The central communication for the plugin occurs through the Atlassian Connect Express framework. This framework greatly simplifies the setup and management of the Jira Cloud connection. In addition, it interfaces with our REST APIs to facilitate the machine learning and visualizer operation. In selecting MongoDB as our database platform, we have been able to quickly implement features such as the visualizer and the undo history for the machine learning component. Additionally, we also exercise the use of the database in caching pre-computed graphs to ensure a responsive visualizer interface. The machine learning component of this plugin utilizes the Keras framework. Keras enables the rapid development of complex deep learning models while maintaining the necessary performance. Our model revolves around a long, short-term memory layer coupled with an embedding layer. Currently, the model is trained offline on data from the project and deployed incrementally. A future possibility is to have this model trained online by integrating user feedback into the model training loop. What is an LSTM network? I'll try to give a very quick rundown here. An LSTM network is a neural network concept that is comprised of multiple modules, shown in the figure as A. These modules take some input X, shown in blue, and some output, some value H, shown in purple. The core concept with LSTM models is the transfer of information between these modules. This leads to the ability of the network to remember information and interpret arrays of data, hence ideal for time series data. This behavior has been utilized extensively in literature for text data. The embedding layer has been implemented using the Global Vector for Word Representations, or GLOVE for short, from Stanford University. These vectors have been trained on a large corpus of data containing 6 billion words. In applying this matrix, the semantics of the input text can start to be realized. Currently, the model is being developed by an experienced developer using standalone programs and then deployed to the server. The drawback here is that the model is very static and cannot learn how an individual team operates. Moving forward, the model would ideally be implemented as an online model, taking the changes and feedback of the user to verify its output. The visualizer utilizes the Cytoscape JavaScript library and allows for dynamic and expressive graphs to be implemented on the fly. To facilitate the core purpose of the visualizer, the library provides a layout algorithm, Cosbilken. This algorithm treats the links between issues as springs. The stronger the relation, the closer the issues will be to each other. This visualization allows the user to identify clusters of critical issues and react to them. Here are some additional remarks about the development of the plugin. We need to incorporate changes to allow deployment to the marketplace, reduce redundancy in the database, especially in how it communicates with other parts of the project, implement additional comparison methods in the visualizer, improve the performance of the machine learning model, and incorporate the user in the training of the machine learning model. Thank you for watching our product demo. If you have any questions, do not hesitate to contact us.